This lesson is going to talk about a z-score. So a z-score is how many standard deviations something is away from the mean. So far we've only had whole number standard deviations. We've had 1, 2, and 3 standard deviations away, which matched up with that 68, 95, 99 rule. However, there are times when a number can fall within a partial standard deviation. So for example, if it was half a standard deviation away, it would be in between 0 and 1 standard deviation. Okay, so it's a z-scores indicate how many standard deviations a single point is from the mean. It is also going to be called the area under the curve. And it's going to tell us whether a particular score is positive, negative, or equal to the mean. So pretty straightforward. If it's positive, if it's above. If it's negative, it is below. And if it is 0, then it is equal to the mean. Now the formula for the z-score, a little crazy because there's a lot of symbols. It's z equals x minus mu over sigma. Remember, sigma is the standard deviation. Mu is the average or the mean. The z-score is what we're trying to get, and the x is going to be what's called the raw score. Essentially, x is what is the problem about? What is this problem about? Okay, so here are some numbers. It's the runs that were scored by the nationals. So we're going to calculate the z-score, the raw score, the average, and the standard deviation. So let's do this. I'm going to tell you what the standard deviation is. So first of all, the average we need to get in a calculator. So in order to get this average, I'm going to add together 2 plus 4 plus 7 plus 11 plus 6 plus 12. And then I'm going to divide it by 6. So the average number of runs scored is 7. The standard deviation, I'm not going to do the formula for. If you go to, let's just actually do this here. If you have a graphing calculator, you can do it on the graphing calculator, but I'm going to show you how to, let's find the best one here. I don't want to write here. I believe it is this one. So instead of doing this whole formula like we were doing in the past, I'm going to just take the numbers and put the numbers in. It is for a sample. We're always going to pick sample, by the way. So 2, 4, 7, 11, 2, 4, 7, 11, 6, 12. 2, 4, oh my goodness. 2. Oh, this is so annoying. 2, 4, 7, 11, 11, 6, 12. Okay. Okay, so the standard deviation, I'm just going to use this calculator, is 3.898. So I'm going to say it's 3.9. Most of the time, the standard deviation will be given to you. So that is going to be the good part about this, okay? Now, it says the z-score for 11 runs is blank. So we don't know what the z-score is, but we do know that the raw score is 11 because the raw score is just what is this problem talking about? So this is talking about 11. So what we're trying to figure out right now is what is the z-score? And when we figure this out, it will tell you how many standard deviations it is away from the average. So we're going to do the formula. Z equals x minus mu over sigma. You do not know what the z-score is. The problem is about 11 runs. The average is 7. And the standard deviation is 3.9. So what the problem is about goes first, minus the average over the standard deviation. 11 minus 7 is 4, divided by 3.9 is about 1.03. So that's how many standard deviations it is away from the average. Now let's just talk about this, okay? Using the z-score and a bell curve. All right, well, let's draw the bell curve. Let's draw the bell curve with an average of 7 and a standard deviation of 3.9. So I'm going to jump over here, 3.9. That puts me at 10.9. 10.9 plus 3.9. The next jump is 14.8. The next jump after that is 18.7. If you were going down, then this would be 3.1. And then you start to get some negative values. So let's talk about this, looking at it visually. This is the average. Okay, the average number of runs scored was 7. The standard deviation is 3.9, so that makes sense. Each one of these is jumping by 3.9. So one standard deviation jump is 10.9 runs, which I know that doesn't make any sense, okay? But the z-score is 1.03. So if you were going to go a little bit over 1, because it's just a little bit more than 1, if you were going to jump a little bit more than 1 space, look where you would wind up. And so that little tick mark is where 11 runs are. And so visually, that's what a z-score is. It's how many jumps away from the mean are you going. So you're going a little bit more than 1 jump, which makes sense because 11 is a little bit more than 10.9. I wish they had one where there was the standard deviation already. All right, let's do this one. I'm going to use the computer to do the standard deviation because typing this in on a tablet is crazy. So I don't know what the z-score is. I know the raw score is going to be 155. That's what the problem is about. And I'm going to use that website I just showed you. I'm just doing it on the computer in the classroom. And I'm just typing the numbers in. So I can just tell you what it is. And be careful because there's a 220 here. All right, so the standard deviation is 43.12. So let's say it's 43.1. And the average, if you add up all of these numbers and then divide, is going to be 174.7. You can get this from that website. So this is not the same problem, but let's say you were on the problem before this. See where it tells you right here? This was the one about the baseball runs. It tells you right here the average is 7. So even though we calculated it, the average was 7. So when I just put in all of these big numbers on the other screen, it told me right away what the average was, so I'm not doing all of this work. Okay, so the z-score is, I don't know, let's figure it out. Z equals x minus mu over sigma. X is what the problem is about, 155. The average is 174.4. And the standard deviation is 43.1. So pause real quick. The question is about the number 155. The average is 174. So your z-score is going to be negative because this 155 is below the average. So let me do this real quick and we will get the z-score. 155 minus 174.4 over 43.1. So it's negative 0.45. And we are always going to round the z-score to 2 decimal places. That's the very important thing here. Okay. So it's negative 0.45, which means that if you were drawing the bell curve, if the average is 174, you're going about, so here's one standard deviation, you're going about half a standard deviation away, but now to the left because it is negative. You're going to just finish doing the rest of these. Before I upload these notes, because it's only 4th period here, before I finish doing these notes, I'm going to just give you guys the standard deviations and the averages. That way you don't have to type them into the computer.